Even though it appears to be, there are no villi here. There are folds, but no villi. And what digestion occurs in the large intestine is not due to our enzymes that we secrete, like in the stomach and small intestine, but due to bacterial activity. We have a normal flora, and they digest things for us, and they make some very important things like B-complex vitamins and also vitamin K, which we need to make many of our clotting factors. Okay? That's why if you disrupt that normal flora, you can have problems, especially in clotting your blood, especially in young, because they're very susceptible. You treat them with broad spectrum vitamin, it knocks out their normal flora, and suddenly they have bleeding problems because they can't make their normal clotting factors. Okay, here we see, again, this is mucosa. If we look at it more closely, you're going to see, again, lots of goblet cells. In fact, it looks like it's riddled with goblet cells. There are even more goblet cells in the large intestine than in the small intestine. So here's a difference. In the large intestine, more goblet cells than in the small intestine. They have a thicker mucosa, no villi. But again, they got the same layers. And here again, you can see, look at all the goblet cells. Looks like you can see it's riddled with holes, which are the goblet cells. Why do you want a lot of goblet cells in the large intestine? What's the large intestine doing?
Digesting.
Well, there's a little bit of digestion there, but the main thing is what?
Absorbing nutrients.
A little of that, but the main thing is?
Excreting, getting it out.
Yes, it's preparing the waste material to be excreted. In other words, compacting the feces, all right? It's a lot easier to move this stuff through a lubricated tube than one that's not well lubricated. So I think you agree, you want a good lubrication, which means lots of goblet cells, okay? That's why you got more goblet cells in the large intestine than in the small intestine, okay? Here again, we got mucosa, and then the submucosa, which is deep to it, okay? That's this stuff here. This one is not well stained is the problem. That's why we don't see it. But this would be submucosa out here. And then the muscle layers, which again are not well stained in this slide. Again, you got the same two muscle layers, but there's a modification here. Okay? You got an intact circular muscle layer, but the longitudinal muscle layer is not intact. And in case in the longitudinal muscle layer, what you have basically are parallel bands of longitudinal muscle called tenia coli. They run basically the length of the organ. Because they're partially contracted, it causes the wall of the large intestine to form these pouches or puckers called haustra. And you can see that, very characteristic of human large intestine. Okay? So make sure you take a look at it. You can see it very nicely on the model. The light gray bands, the lines that you see are the tenia coli. Those little pouches you see, the large intestinal wall, those are the haustra. Okay? All right. The liver. Let's take a look at the liver.